Okay, you guys, before we look at our last review section, I just want to go back and make a correction. I don't know why I keep getting you guys mixed up with another class I'm teaching, but I apologize for that. But the rational expression material is in R.7, so I apologize for that. I think you'll even notice that there is no R6 on the review. So for your my math lab, it's R7. What follows is R.8. So it's all about radicals, their notations, etc. So let's take a look at that. Let's again get this idea back. Very important idea for what we're going to be seeing a lot in our math class. So radicals. So first of all, when you see a radical, it's pretty clear, right, that it's there, right? You see that radical looking symbol. The number that's sitting right in that little arm, if you would, that elbow, is called the index. So we're looking at the cubed root. However, another way that a radical can present itself is with a fractional exponent. So when I see this 1/2, the denominator is telling me what the index is, and the 1 is the power that the expression is. So this is basically the square root of 25 minus 9, whereas this is the cubed root of 8 squared. All right, so a little bit of a fractional notation along with radicals. In terms of evaluating these radicals, I'm basically asking myself, what number can I raise to the third power and get -8? Right, that's kind of what's going on there. And I think if you thought a while enough about it, we're looking at -2. All right, so the cubed root of -8 is -2. To do this one, I first have to perform the subtraction underneath the radical. So we end up with the square root of 16. And of course, the value, right, we're looking for a number that I can square to get me 16. Now, this is a little funny because there's actually two numbers that do this. There's +4 and there's a -4. The +4 is what we call the principal square root, and it's the one we're talking about here for this particular example because there's a positive connotation associated with that radical. But do be aware it's going to play a role in square root properties and whatnot. There's actually two answers there, a plus and a -1, technically speaking. Here again, like the last example, I might want to simplify what's in there first. So 8 squared is 64. And of course the cubed root, right? What number can I cube and get 64? Well, that's +4. All right, and unlike square roots, cube roots are what they are, right? So -2 is the only one that I can cube to get -8, and +4 is the only one that I can cube to get 64. Square roots are a little funnier, right? Because again, -4 squared is 16, and -4 squared is 16. So we're really going to have to pay attention to what we're doing, and am I talking about a principal square root? Am I considering all possibilities? It plays a pretty role, but cube roots are really nice. They are who they are. All right, looking more into radicals, another thing we do is we simplify radicals. One thing that we can look for is that the index, right, has to be larger than any powers that are inside here. If we take a look at 64, 64 is basically 2 to the 6th power. All right, so we're looking at the cubed root of 2 to the 6th, x to the 4th, y to the 8th. And so, unfortunately for us, all the powers inside the radicand are higher than the index. So that's something that needs to be simplified. Now, a shortcut to all this is to use the fact that we're looking at fractions here. 6/3, so we have 2 squared coming out. 4/3, well, we have an x coming out and an x staying in, right? Because 3 goes into 4 one time with a remainder of 1. 3, right, we're looking at 8/3. So 3 into 8 goes in twice. So we have y squared. And then I think y squared stays in because 3 goes into 8 two times with a remainder of 2. So that's kind of a shortcut looking at these as fractional exponents way. If you didn't quite understand what I said there, right, what we're trying to do is if my power matches my index, the radical goes away, right? Here's a real famous radical rule. So if my power matches the index, right, these basically undo each other and we're just left with the a. So if you want to look at this another way, right, this is 2 cubed times 2 cubed, x cubed times x, y cubed, and y squared. So 3 and 3 gives us 6, 3 and 1 gives us 4. 3 plus 3 plus 2 gives us 8. And we're looking at the cubed root of that. So there's a 2 cubed and there's a 2 cubed. So that's why I got the 2 squared, otherwise known as 4. There's an x cubed and there's an x staying in. So that's how I got an x and an x. There's a y cubed and a y cubed. So I have y squared coming out of the radical and a y squared staying in the radical. So one way I kind of talked you through a shortcut, and the other I actually broke it down and showed you the rule that I was using. Either one is good. Another area where radicals need to be simplified is an example of the next two. I have a radical down in the denominator. We usually do not like radicals down in the denominator. So what we have to do is what's famously known as rationalize it. But this also plays a different role depending on what's down there. Here there's only one radical down there, so I would only have to multiply by, I need another fifth root, and I need something to match it. Now again, what I'm trying to do is get my power to match the index. Right now my index is 5 and my power is 2. So what I actually need to do is multiply by the fifth root of x to the third. If I do the multiplication, right, it's top to top, bottom to bottom. So we get 5, the fifth root of x cubed. And down here, a fifth root times a fifth root is a fifth root. X squared times x cubed is x to the fifth. Power matches the index. So we have 5, the fifth root of x cubed all over x. And there's my simplified fraction. Again, the denominator has been rationalized. C, though, we just don't have the radical by itself, right? We actually, it's a term involved in a binomial. So when that's the case, the thing I need to multiply by is famously known as the conjugate. All right, so I have the same two terms, 4 and the square root of 3. I was subtracting, I now need an addition. So to multiply, again, it's top to top, bottom to bottom. And on the bottom, we do a foiling out of what's down there. What I'm also going to do is use the fact that this is the difference of squares. So this is 4 squared minus the square root of 3 squared, which gives us 16 minus 3, which is 13. So the top, let me kind of sneak in this answer here. So on the top, we get a 16 plus 4 square root of 3. And on the bottom, we have a 13. And so there's our final answer for letter C. That would be the simplified form of that fraction. If you broke out a calculator, you'll notice that the decimal value you get for this would be the same as this. They're equivalent fractions because I multiplied by 1. And I chose the multiplication wisely because it cleared out the radical down in the denominator, rationalizing my denominator. Okay, so hopefully that gives you some memory jogs. Of course, if you need more practice, which I think many of you probably do, our point 8 is where you want to go and get this practice in. Last but not least, how do I add, subtract, and multiply and divide radicals? Well, division basically comes down to what we did up there. All right, you actually don't divide radicals, you rationalize the denominator. So that one's taken care of. But adding and subtracting, what we come back to is this idea of combining like terms. So here, when I look at the subtraction, I notice that the radicals are different. All right, so technically I can't subtract. However, the square root of 12 breaks down into the square root of 4 times 3, which is 2 square roots of 3. So this becomes 7 times 2 square roots of 3 minus 2 square roots of 3. Multiplying here, this is 14 square roots of 3 minus 2 square roots of 3. Now they're like, right? This has square roots of 3, that has a square root of 3, so 14 take away 2. We have a final answer of 12 square roots of 3. Okay, and the next one, we are multiplying. So to multiply, what we do is we FOIL, or what we knew as distribution. So when I distribute, 2 times 3 would give us a 6. My outer would give us a 2 square roots of 5. My inner would give us a positive 3 square roots of 5. And then my last, well, a positive times a negative is a negative. And we have the square root of 5 squared, or what would commonly known as the square root of 25. That's 6. These guys combine to a square root of 5, and then the square root of 25 or the square root of 5 squared results in a 5. These guys now are like, and we end up with the answer of 1 plus the square root of 5. Last but not least, we're squaring a difference. Again, fight the urge to apply that power to each, because that's not how that works. What happens is we are squaring a difference, which means I've got that. So we're basically foiling it again. So I got 25 minus 5 square root to 2 minus 5 square root to 2. How about I just write that as minus the square root of, or excuse me, plus, right? A negative times a negative is a positive. Square root of 2 times square root of 2 is square root of 4. These two terms are like. We get 25 minus 10 square roots of 2, and then plus 2. So combining my, we get 27 minus 10 square roots of 2. And there would be my final answer there. All right, so again, this is an R.8. And if I may, R5, R7, and R8 are very important, because a lot of our skill building, everything else is important as well, but it seems like we do a lot of factoring, we work with a lot of rational expressions, and we work with a lot of radicals in this class. So make sure you review those sections and you're ready to go and build on that foundation so you guys can be great college algebra students. All right, so keep studying, get that practice quiz done and pass it. Let's make sure you're ready to start college algebra.